Living beings, unlike many devices, can heal themselves after an accident, such as falling down the stairs, giving you colorful bruises. Nevertheless, as a well-known Dutch saying says, voorkomen is beter dan genezen. Freely translated in English, prevention is better than healing. But it actually means better safe than sorry. And this is so true for batteries, but then where we can intervene to self-heal battery, for that we need to unravel the battery and see where things can go wrong. And we choose the lithium-ion battery for that. When opening a lithium-ion battery, please never do that at home yourself, we have several places where things can go wrong. To summarize these, aluminum corrosion, structural disordering, electrode powder microcracking, oxygen evolution and degassing, nickel, manganese, cobalt, iron dissolution, electrolyte degradation, dendrite and solid electrolyte growth, pulverization and electrical isolation, as well as copper dissolution. Self-healing of aluminum corrosion, oxygen evolution and degassing, nickel, manganese, cobalt, iron dissolution, electrolyte degradation, dendrite and solid electrolyte interface formation, and copper dissolution are degradation processes that are too difficult to allow self-healing, and here prevention is more important. This means we must focus on the electrode material itself once it comes to self-healing to prevent degradation. The challenge for the next generation lithium-ion batteries with high temperature density and power is mechanical fracture due to the volume changes occurring in the electrode material during cycling. Up to now, improved stability of nickel manganese cobalt type cathode has mainly been obtained through preventive steps, such as doping by specific elements to prevent structure degradation and fracture, and once that may happen, by using conductive coatings, mainly of organic origin, to offer strong elasticity to keep cracked particles together, allowing still electrical contact. Nevertheless, if it is possible to use the dopants, the additives, to migrate towards the sites where the crack would form, it might be possible to avoid the crack formation. This could be a dopant that is sufficiently mobile and has probably a little larger ionic radius, and so allowing higher strain under the induced stress. The negative electrode expansion, for instance of silicon, is a serious issue which leads to pulverization and loss of contact. An approach of self-healing is the addition of low melting point metals, such as gallium, with a melting point of 29 degrees C, so as to form locally an alloy which allows to close the created cracks. Obviously, the metal of choice should be melting in the range of the operating temperature of the battery. Also, certain binders, which are used to keep the particles in the coating, may be made active for self-healing by introducing cross-linking via ions or additives, which have been added already in the electrolyte. From whom this still might be too far away, recently at SINTEF in Norway, researchers in this lab are creating a self-repairing and environmentally friendly EV battery, which includes binders that are doing this job.